Find three numbers of a GP whose sum is 14 and whose square, when added, gives a total of 84. So in a geometric progression, let's take these three terms as A, AR and AR square, right? Now the underlying assumption that we are taking is, although it's not given to us that these are consecutive, we are assuming these numbers are consecutive, right? Otherwise, in a GP, let's say if this was AR3, AR4, even this and this are three numbers of a GP. But our assumption is that these three numbers are consecutive, right? Now what are we given? We are given that the three numbers, the sum is 14. So A plus AR square is equal to 14. And whose squares? So if you add up the squares of these three numbers, let's call them as A square plus AR square plus AR square is equal to 84, right? So what you're given is that the sum of these three numbers is 14, the sum of their squares when added is 84. You have to find out these three numbers, right? So if I move forward with this one, can I take A common here because it's there across all these three items? So I can just write this as 1 plus R square is equal to 14, right? Now the other idea which I will have is, once I have this equation, I will try to convert this in such a manner that I can reach somewhere close to here, right? So can you think of something? Let's just see if opening up these also makes a difference. AR square can be written as A square R square plus this can be written as A square R to the power 4 is equal to 84. Now if you notice, A square is common in all these three. So can I take this as A square, right? 1 plus R square plus R4 is equal to 84. But my problem is, even at this stage, I haven't completely reached a situation where I can substitute this like this, right? So I need to solve this a little further, but how? It seems there is no way through which I can get through this. So should I try something different, right? Should I do a square of this equation? If I do that, what do I get? I get A square, which is square of this number, 1 plus R square is equal to 14 square. 14 square is how much? 140 plus 56, 196, right? Now, if I open this further, can I also write this as what? A square, right? In this term, let us put it in such a way that we put this 1 plus R as A and R square as B, such that we get this as A plus B whole square, right? If I do it like this, then what do I get? A square, which is 1 plus R square plus 2AB or 2R plus B square. B is how much? R square, so you get R4 plus 2AB, 2 into R square into 1 plus R, right? Does it solve the problem? No. So we need to do certain further juggleries. Now, can I just pick up the relevant portion from here in such a manner that I can substitute this with this? So if I were just to open all these brackets, what do I get? I get 1 plus R square plus 2R plus R4 plus 2R square into 1, 2R square plus 2R square into R, 2R cube is equal to 196. Now what do I have here? 1 R square plus R4, 1 R square plus R4. So I can write this as A square into 1 plus R square plus R4 plus A square into the balance 2R plus 2R square plus 2R cube is equal to 196. We know that the value of this is how much? 84. 84 plus. Can we also write this as a square in any case is there. Can we take 2r as common from inside? Right? Then you are left with 1 plus r square is equal to 196. Right? This 84 moves to the other side, so you get 196 minus 84. Now again, how do we solve this? We don't know the value of this, right? But what we know is that a into 1 plus r square is equal to 14. So can I just write this as 2ar into a into 1 plus r square is equal to 112. In any case, we know this value is how much? 14. So we divide this by 14. So we get 2ar is equal to how much? 8. ar is equal to 4, or a is equal to 4 upon r. Right? Once I've got the value of a out here, then can I solve the value of r as well and a as well? Yes. And what do we do for that? We'll put on this value of a in the first equation. So you have 4 upon r as the value of a, right? Let me just take another question. I'll just remove this from here. So you have a 1 plus r square is equal to 14. A into 1 plus r square is equal to 14. A we've got what is the value of a that we've got? We've got a is equal to 4 upon r. So 4 upon r into 1 plus r square is equal to 14. Or if you just open the bracket 4 times, 4 plus 4r plus 4r square is equal to 14r. Right? Make this as equation 1, 4r square minus 10r. 14r when it goes this side becomes minus, plus 4r gives you minus 10r, plus 4 is equal to 0. Or you can also write this as 2r square minus 5r plus 2 is equal to 0. Why? We just divided the entire side by 2. Right? Can I now solve this question, please? So we can write this as 2r square minus 4r minus r plus 2 is equal to 0. 2r, let's take it as common, r minus 2, minus 1, r minus 2 is equal to 0. So we get r is equal to 2 and 2r minus 1 is equal to 0, or r is equal to 1 by 2. A was equal to 4 by r, or 4 by 2, 2. And if you use this value, you get a is equal to 4 upon r is equal to 8. Now once you've got the value of a and r, you can easily plug them into these 3 terms, right, and get the sum as 14. What were the 3 terms? A. So a was how much? A is equal to 2 for the value of r is equal to 2. So a is equal to 2, ar will be 4, r square a will be 8, 248, right? And that's the answer.